Okay, we are going to start shortly. Okay, I will start now. Is everyone able to hear me? Anyone able to hear me? Yes, okay, great. Thank you. And are you guys able to see the slides? Great, great. Thank you. We'll quickly build up where we left off last time. And, we started off the course with the brief introduction of internet structure. We talked about the layers. We talked about encapsulation. Um, what happens when a packet goes from a source to the destination at the application layer. In the source machine, it travels down the stack, and at each layer of the networking stack, a new header is added. And the header is added because we want to make sure that we put in the source and destination addresses within that header. And then the packet travels through the physical layer, link by link, hop by hop, all the way to the destination, received at the physical layer, passed on to data link layer. The data link layer strips off the data link header. The data link header is stripped off and the packet is passed to the IP layer. And then the IP layer passes the packet to the transport layer after stripping its header. And then the actual payload, the actual application layer data is given to the application layer. So this happens in all sorts of communications, and we can have many different application layer protocols available to us. Some of those protocols we are very familiar with. We use those every day, HTTP, and we started off last time with the HTTP. We said that HTTP is a request response kind of a protocol. Request response kind of a protocol. Your browser sends a request to a web server hosted somewhere, and the server responds with a file that is displayed nicely with your browser within your browser. The browser does all the interpretation that, some of the text should be bold, some of the text should be italic, font may be changed, an image may be displayed, a video may be displayed, and things like that. Now, we also said that when you request for an HTML file using HTTP protocol in your browser, then the HTML file is displayed on your machine. That HTML file may contain just text, or it may also contain many other objects. Now, those objects, just like the base HTML file, those objects are separate files: an image file, a movie file, um, a PDF file, for example. So these embedded files, or these contained files, are linked from the base HTML file, are linked from the base HTML file. And your browser, when it parses the base HTML file, it finds the links to those embedded objects, and it sends the requests behind the scenes. It sends the requests for each of those embedded objects to the server, and the server obliges and sends back the requested objects to the browser. So all the objects are displayed within the browser. Okay. Um, so we are good so far. We are good so far. Any questions at this point in time? Any questions? किसी का कोई question है? No questions. So we are doing good. Okay. So so let's move on to very quick review of the slides that we saw last time. Web and HTTP, web components, and web infrastructure. As we said, it consists of clients and servers. And then when you request a web page, that is basically an object, a base HTML file, a base object or base HTML file, which may contain some embedded objects. So you send HTTP request for an object, which could be the base HTML file or one of the embedded objects, and then you get the response. Okay. The protocol for exchanging these requests and responses, the protocol used for that is HTTP. And you can actually see what is the format of HTTP request. What is the format of the HTTP request? We will look at the HTTP request structure. In fact, we did look at it last time. We'll just quickly go over it again. So in HTTP is the central part of an HTTP protocol is a URL, uniform resource or record locator, which consists of a protocol, the host name, port, directory path, and the resource that you are requesting. An example of that is a server or host name, which is this trend.lums.edu.pk. Okay, and then the protocol, which is this HTTP protocol. Your browser may support other protocols. For example, these days, almost many browsers, or almost all the browsers, they support the FTP protocol. And then you have a port number. It's in brackets because this is optional. If you don't provide the port number, this is defaulted to 80 for HTTP. If you have a secure version of HTTP, then it will default to 443. Then you have this directory path, and this directory path, by the way, is not on your local machine. This directory path is on the server machine. So you are contacting this server with this host name, and you are specifying this directory path, which is folder 003/sub/docs. Okay. And then finally you have a resource, and that resource is your flow.html, which is the base HTML file. Now this HTML file may contain embedded objects, and your browser behind the scene will send the request for each of those objects. And similarly, we have another example down here. Okay. And we said last time that these HTTP requests can be for very complex type of objects. So for example, this could be program execution. So for example, in the first example here, cooltranslation.com, basically you send a word to this website, and this word is passed on as a parameter. The website will have a backend directory or a database dictionary, and it will look up this word. It will look up this word in the dictionary, will generate an HTTP page, an HTML page on the fly, will generate an HTML page on the fly, and will send the translation of Sublime to you. The reason that you have to generate the HTML page on the fly is because the server didn't know what word you are going to ask the meaning for. Okay, so basically they will have a base HTML page, but there will be some, it would be a templated version. The meaning of the word will not be written in there. And once you send the word, this Sublime word is sent within the request, then the server will say, so this client is asking the meaning of the translation of Sublime, and will translate Sublime and by using the dictionary which is hosted at the server, and then send the HTML page back to you by after inserting the meaning of Sublime into the text itself, into the HTML file itself. Okay, and similarly you can have the shopping cart items, which could be very long URLs, just like this in the case of eBay. Okay. So URL, the protocol could be a variety of protocols: HTTP, HTTPS, RSTP, etc. Host name is the DNS name or the domain name, or it could be an IP address. You can access the server machine by using the IP address. Typically, you don't know the IP address. You do know the name. So everyone knows www.cnn.com. You don't remember the IP address of cnn.com. Okay. So somebody else will do that translation for you again behind the scenes. And that guy is the DNS, Okay. So once again, the port number is the default value, which is 80, or you can specify a port number of your choice. But you need to make sure that the server is running on that port. By default, the HTTP servers will run on port 80, which means that they can accept the requests coming in on port 80. And similarly for HTTPS, it is 443. Then you also have to specify the directory path and the resource. So HTTP is using what we call a client server architecture. The server is almost always on and well known. This is a well-known server. Software used for that is Apache, Nginx, and many other servers available these days. The clients which initiate the contact to the server, they are your browsers, could be Firefox, Chrome, etc. And the request reply protocol, which we will go into the structure of, it runs over the TCP. Remember we said that all the applications, all the CEOs, vice presidents, they need the services of the secretary. And that secretary for the HTTP is TCP. Is TCP. Why? Because TCP provides reliability. We could not run HTTP over UDP because UDP does not provide reliability. UDP says that I will make my best effort, but if something is lost, you are on your own. Okay. So, so it is possible that you run a protocol over UDP as long as that application layer protocol does not require reliability. HTTP, we know that it requires reliability. Why? Because in HTTP, we are requesting a file, and this file is sitting on the server. And this file which is sitting on the server, you need to make sure that every single bit of that file is reflected, is transmitted to your browser as it is. Any single bit error in the file, any missing piece in the file, and you are not going to be able to construct the file. You're not going to be able to parse the file. It would be meaningless for you. Okay. So HTTP is also stateless. Stateless means that you send a request and the server responds back to you, and then everyone forgets about this request. Then you send another request, and the server responds to that as well. No state is maintained. Okay. So that's how HTTP will work. However, that is not something that we witness. We actually witness that state is maintained. You go to gmail.com, your mailbox is always there. You don't have to send the HTTP requests and including your username and password with every request. So somehow the state is maintained, but HTTP itself does not maintain the state. Similarly, if you are buying something online and you put things in the shopping cart, the shopping cart keeps showing you the items as you are adding those items into the shopping cart. Okay. So, so that means somehow the state is maintained, but inherently HTTP protocol does not provide state maintenance. Okay. So we need to do something in addition to HTTP to make sure that the state is maintained. Okay. And we use various different methods to maintain the state in HTTP. In addition to HTTP, how do you maintain that state so that you don't have to log into Gmail with every click, or log into Facebook with every click, or keep adding, so you can make sure that you can keep adding items in your shopping cart as you are purchasing items on an e-commerce website. Okay. So HTTP also follows the ASCII format. Okay. So some of the very basic steps in HTTP request response. We said that HTTP runs over TCP, which means that you first need to establish a TCP connection. The secretaries, they need to be ready in advance. Okay. So first you will establish a TCP connection. So we don't know the details of establishing the TCP connection until until the next chapter. Um, but um, but in the case of TCP, you must need to send a request and get a response and then give an acknowledgement. This is called a three-way TCP handshake. This three-way handshake ensures that both the client and the server, they are now ready. Okay. So this is something which the secretaries will do among themselves. The CEOs, they do not need to know about it. They do not need to know about it. They will not know about it. Okay. So this will happen again behind the scenes before you can actually send an HTTP request over a TCP connection. So what has happened so far in this picture is establishment of a TCP connection. Okay. Once the TCP connection is established, now you can send the HTTP request. So maybe with this final TCP acknowledgement, you will bundle the HTTP GET request. Normally it is bundled, but you can send the separate packets also. You can send the HTTP GET request, and then you will get a response. Then you send another request, another response, another request, another response. So these purple lines here, these tell you the HTTP interaction, request, response, request, response, request, response. And you must have a TCP connection. These yellow lines here, or green, whatever color is that, these yellow or green lines, these are the TCP connection establishment. So see, you first have to establish a connection. You need to waste a little bit of time. To make sure the connection is established. Okay. So that means the application layer view or the HTTP view, is only limited to these purple lines, while the TCP view is limited to these yellow lines. We do need these yellow greenish lines before you can make a request of purple line. Okay. Any questions so far? So after every HTTP request and response interaction, you will close the connection. It is possible that you will close the connection after sending one HTTP request, ek bheji, and then you got the response for that, and then you close the connection. If you want to send another HTTP request, establish a TCP connection altogether, once again. So this connection close means that you have closed the TCP connection. TCP connection is closed. If you want to send a new HTTP request to the same server, you will have to re-establish the TCP connection over again. Okay. So the format of the HTTP request said that the format of HTTP request is, there is a request line. This first line here is called the request line. Okay. And after that, we have these header lines. And this request line has the method, which is the get method. We also have a post method. If you want to send something, you post something to the server. For example, if you want to upload a file to the server, then you will use the post method. If you just want to send a request that I want a web page, then you will use the get request. Okay. Now, then there is a resource which contains the directory path as well as the HTML file that you are interested in, or the object that you are interested in. This could be an image object. This could also be a audio file. This could also be a video file, PDF file, could be anything. And then the protocol version, which is HTTP/1.1. The present day, in the present day deployments, we have HTTP2, which is available. The one previous to 1.1 was 1.0. Okay. And then we also have these header lines or request headers. These header lines provide additional information or modify the request. So for example, they have the host, they provide the user agent. User agent means that what kind of a browser I am using. So server may decide. By the way, sometimes when you access the web pages using your desktop or laptop, you get a web page. If you view the same web page, web page using your mobile phone se request bhejte hain, you see a different page. Although you are sending requests to the same web server, same address. How do you see that different page? It's because the server notices that what kind of a user agent you are using. If you are using a user agent which is related to which indicates that it's a web browser, on a mobile phone, they will send you a different content. If it is for a desktop, the user agent is for a desktop, then the server will send you a content which is suitable for your screen size. Okay. So very, very interesting way of server to distinguish between the different type of clients, what kind of a real estate they have on the screen, um, and then connection close, accept language. So many other headers can also be included. And then you have this optional data. So remember we said that we can actually post some data. Post some data means we can upload a file on a web server, and this post data, the file contents will be in this empty region. If you are not interested in uploading something, you are only interested in sending a request and getting the response, then you will leave this place empty. This place will be empty. Okay. Next, this was client to server request. Okay. Obviously, when you send a request, you would have a response, and the response will look like is similar. Okay. First of all, you will have the protocol version here, and then you have the status code and the status phrase. Both of these indicate the same thing. 200 OK means everything is all right, and what follows is the requested web page. You might sometimes get a 404. 404 kabhi aa jata hai. 404 means that you are unable to access that object, or the object does not exist. Okay. And then there is a whole list of status codes which HTTP has specified in the specification in the RFC. Remember we said that RFC's request for comments are the standard documents which are standardized by the standardization bodies. Internet Engineering Task Force is one of the bodies which standardizes most of the internet protocols. Not all, but most of the internet protocols. Okay. Then just like in the request header, we also have a header in the response where the header lines indicate some information. So for example, you have a date here, 6th August 2006, which means, the current date, present date. Last modified, when was this resource, this object last modified? That is also given here. Based on this information, you can actually figure out how stale is the information that you, is it. If it is a news website and it's a very old date here, that means the news is pretty old. Okay. And then the content length and content type, and then lots and lots of data. Whatever you have requested, that file will come right here. The HTML file will be here. Okay. You can actually view this communication. Between the client and server by using, last time we said that there is a tool that you can install by just downloading it for free. It's called Wireshark. You can install it on your machine, and you can actually view all the packets going in between the client and the server. जो आपकी machine से निकल रहे हैं, you can watch all of those packets, all the packets which are received at your machine. You can watch all those packets as well. So it's a very rich tool. You can do all sorts of filtering there. In fact, you will not only be able to see the HTTP request and response, you will be able to see everything, because it captures the packet which are received on your physical layer and are at the data link layer. So you will be able to see the data link header. You will be able to see the IP header. You will be able to see what is going on at the IP level, what is going on at the transport level. You will see the port numbers. Port 80 will be there as well. Okay. So so make sure that you play with Wireshark. We will have a very small exercise in which you will install Wireshark on your machine, and you will do a little bit of exercise as homework. Okay. So these response headers, they contain additional information about the file. Okay. So how do you view the HTTP interaction? So one thing that we have just described, that you can use Wireshark. And you need to make sure that there is no network activity, no other network activity on your computer. Of course, you want to see some network activity, but you want to observe. You have to have that network activity, but no other network activity on your computer. Even if you have other network activity on your computer, you can use some sort of filtering in the Wireshark program. You can specify your IP address. You can specify the IP address of the server machine that you can easily find out, and use your browser to fetch a page and dig down into the packets that are captured. You can capture all the packets. You can actually see this TCP interaction, the connection establishment of TCP before you send the HTTP request. उससे पहले TCP requests जाएंगी और response आएगा with a three-way handshake. You will be able to see that as well, which is great. So you would know exactly what is going on. Please do spend some time on learning Wireshark. Very useful in good understanding of the networking stack and layering and encapsulation. Okay, you can also do the following. You can compose the HTTP request yourself. Normally you type the address in your web browser, right? And your web browser, it's the responsibility of the web browser to make sure that what you type there, www.cnn.com, gets translated into something like this. Gets translated into something like this. Okay, so gets translated into this. Your web browser will be taking care of this. It will do something like this. Although you have just typed cnn.com, but it is making sure that this complete HTTP request is formed. So maybe in your browser you will type, in the browser window you will type www.someschool.edu, which is written here, /someder/page.html, and behind the scene your browser will form this HTTP request based on what you have typed in the browser window, and then it will send the request, get the response. Okay, so what you can also do is, without the help of browser, you can actually make the HTTP request, craft the HTTP request yourself. So you can connect to a server using the command line. Command line को use करके आप server पे direct connect हो सकते हैं, ठीक है? So open up the command line window on your machine, and then there is a program which is called Telnet. You may have it already installed if you are on Unix or Mac. For Windows, you may have to install it, or maybe already there. So you will use this program Telnet, which is basically, Telnet is, you are connecting to a remote machine. You are connecting to a remote machine. You will provide the server name. So you will provide the server name, and then you will also provide the port number that you are looking to connect to. See, in the browser, you don't have to specify the port number, but remember, the browser knows that if you don't specify a port number, it will default it to 80 anyways. So behind the scenes, वो 80 में convert कर ही देगा. But if you are sending the request yourself, you will have to put this 80 yourself. So once you are connected, then this line here has established a TCP connection. That three-way handshake is finished after you do this telnet server name and port number. So that means a TCP connection is established with the server at this port number. If the connection is failed, you will be notified. If the connection is successful, you will not be notified. It will give you a blank, screen, and where you can type your HTTP request. So for example, you can type this get request yourself and path to the resource and specify HTTP 1.0. You can actually skip all the headers. Those are optional anyways. All the header lines you can skip, and then HTTP 1.0 or 1.1. And once you send that, you will see that in your command window, you will see an HTML file coming to you. We'll see this HTML file coming to you. Okay. So you please try that at home. If you have any questions, the TAs or myself, we can help you with that. Okay. So HTTP is stateless. We said that it is stateless, which means you send a request, it will respond and will forget about that request. Okay, will forget about it. Okay. So each request response is treated independently. The servers are not required to retain the state. This is good as it improves the scalability on the server side. The failure handling is easier. You can handle higher rate of requests because the server doesn't need to maintain the state. Server has to do very little work. You send a request, it will respond and will forget about you. It does not need to maintain an internal data structure for each of the user who's sending the request to the server. So very, very efficient, very efficient way of handling things. So this is good in a way. This is good in a way, but it might be bad because some applications, they need persistent state. They need stateful information. And some of those applications, they require to uniquely identify the user or store temporary information about the user. Okay, so for example, shopping cart. You don't want to add some item to your shopping cart on an e-commerce website and add the next item and looks like the first item is gone. Okay, you don't want that. You want the state to be maintained on the server side. Similarly, user profiles on Facebook, you don't want to be typing your username password on every single request. Similarly, usage tracking and lots of other applications where you require a stateful sort of an information. So, but we do know that HTTP is not stateful. It is stateless. It is stateless. So how do you maintain the state? So how do you maintain the state in a stateless protocol? किस तरह state maintain करेंगे stateless protocol के अंदर? Maybe you will need to do some magic, some trick on the server side as well as on the client side. दोनों साइडों के ऊपर आपको कुछ trick करनी पड़ेगी, and that trick is called cookies. Is called cookies. Okay. So what are cookies? What are cookies? The cookies are pieces of information. It's a piece of information which tells the server that this is a repeat client, that this is a repeat client. So you have a user here using some browser on the left hand side, and on the right hand side, you have a server. Okay. So client side state maintenance, the client will store a small state on behalf of the server, which is stored in the cookie. The client will send the state in all the future requests for the server. So I will give you an example. So for example, so this is a client on the left-hand side. This guy wants to send some request to this server and wants the server, this guy wants the server to remember him, So the first request which goes to the server, it's just like a normal request. Okay. So so if you are a server, then you would obviously respond with the HTML file. Once you respond with the HTML file, within the response, you will include a response header. Within the response, you will include a response header, and that response header will have this value set cookie is equal to some number XYZ, 3452, for example. Okay. So this number XYZ is now stored on the machine of the customer. ये इसके browser ने अपने पास store कर लेना है. Okay. So the guy will store this number XYZ, and along with XYZ, it will also store the identity of the server, whether this is www.amazon.com or www.lums.edu.pk or www.cnn.com. So why it is necessary? Because this cookie is set on your machine by a particular server. जिस server ने वो cookie set की है, आप उसी server को वो cookie देना चाहते हैं दोबारा. So next time when you send the request, when you send the HTTP request to the same server, you will include this cookie information again in the request header. So ये request header में ये cookie is equal to cookie colon XYZ, you will include this information, just like you were including your user agent, that my user agent is Mozilla 4.0. Now, in addition to that, you will include this cookie information in the same header, same HTTP request header. So far so good. Make sense? Any questions so far? Cookies के बारे में कोई सवाल? Great. Okay. No more questions here. Huh? So these cookies will be able to provide the authentication. Okay, it's very interesting way of maintaining the state. Remember, in this case, the protocol is not maintaining the state. It's the state is maintained by storing some information on the client side and some information on the server database. Server has stored in the database that this cookie XYZ was stored corresponding to a particular user John. Okay, so उसने John का profile रखा होगा और XYZ वहाँ पे साथ रखा होगा. So when John sends the request XYZ, तो उसको पता है कि John की shopping cart के अंदर पहले से 6 items पड़ी हुई हैं. वो 6 items के अंदर एक 7वीं item और add कर देगा. Okay. So now let's take a look at some of the HTTP performance issues. So obviously, whenever we use the internet, we need to make sure that when you send an HTTP request, you get a response as quickly as possible. So Aisha, you have a question, please go ahead and ask.
Yes, sir. Sir, I wanted to know, for example, if I put something in my shopping cart and then I clear my cookies, so will that information be lost?
The information will be lost. The information will be lost. If you clear the cookie, the information will be lost.
Okay.
Okay, but see, what will also happen is on the server side, the information, if you clear the cookie is cleared on the client side. You cannot go and clear the cookie on the server side. So on the server side, the cookie will still be there, although when you send the request, the server will not recognize you, so it will not show you the items in the shopping cart. However, normally what you do is that you also have accounts on these web servers. Okay, so for example, if you go to daraz.pk or amazon.com or alibaba.com, then you will log in again. You will provide your username and password, and it will say, oh, it's the same user. It's the same user because it has provided, you have an account with that web server. And then the server has this information that this guy previously has stored these items in the shopping cart, will show that information to you. On many websites, you can also do shopping. In many e-commerce websites, you can do shopping without having an account. So if you do that and you clear the cookies somewhere in between, then your shopping cart is lost and you will not be able to recover that. If you don't have an account on the server. Okay, does that answer your question?
Yes, sir.
Okay, great. So so some of the performance issues we would like to handle is, everyone would like that when they send the type www.cnn.com, the page loads immediately as soon as possible. I don't want to wait too much, so I would like the response to be coming to me from the HTTP server as soon as possible. Okay, so let's identify some of the performance goals. What are the performance goals of HTTP? Okay, so the performance goals will have multiple dimensions. One is for the users, one is for the service provider, one is for the content provider, and so on. So for the user is interested. What is the goal for the user? The performance goal of HTTP for the user is that it should allow fast downloads. Okay, so fast download means that I should be able to get the content as soon as possible. By the way, this does not mean low latency, because if a server is too far from you, there is a certain period of time that the packet will take from the server to you. What you are interested in is having fast download, that if you request a file, that file is available to you as soon as possible. You also want high availability. You don't want the server to be down. Okay, yeah, you want high availability, which means that whenever you send the request, you always get the response. Okay, so this is from the user perspective. What is from the content provider perspective? And content provider is the guy who serves the content to you, the server, not your ISP, not any middle ISP, it's the server. CNN.com, Amazon.com, ESPN Cricinfo.com, these are the content providers. So these content providers, they want to see happy users. That's how they make money. So they want to see happy users. So if they want to see happy users, they need to be able to provide fast downloads and high availability. They also want a cost-effective infrastructure. Infrastructure. So, for example, ESPN cricinfo.com, their content is hosted somewhere, maybe at multiple places around the world. They don't want to spend too much money on that infrastructure. Okay, so they don't. They probably, you can guess that ESPN cricinfo.com, they will have their content, their files hosted at multiple places in the world, Same thing goes for CNN, but they cannot rent space at everywhere or all of those places in the world, put their servers in there. That would be too costly and nightmare for them to buy property in all countries and all regions, and or rent properties in all regions, maintain those properties, maintain the data centers where the servers are hosted. So they would want some cost effective way. Maybe they will outsource it to somebody. कहेंगे यार हमारे लिए ये आप host कर लें, ठीक है? And that is what actually happens. We have these entities called content distribution networks, CDNs. Akamai is a big example of that. And the job of these CDNs, content distribution networks, is to make sure that these content providers, they get the services from the CDNs. So we have an Akamai CDN server in Pakistan. Facebook, YouTube, CNN.com, etc., Wall Street Journal, they can get their websites hosted within Pakistan, the content replicated within Pakistan. Okay, but they will not do that on their own. They will just ask Akamai that we will pay you this much money, please host our files. Okay, so content providers, they would want to use cost effective infrastructure. Similarly, the network would want to be happy as well, because the network does not want to be overloaded, So how do we make the users happy, through fast downloads? So for making sure that we have fast downloads, we will need to improve the HTTP performance to compensate for some of the TCP's weak spots. Okay, when we go to the next chapter, we will find out that TCP is not the most efficient. There are some weak spots that you can probably compensate by using HTTP. So for example, TCP limits the bandwidth at which you can download the data. TCP limits that bandwidth, the rate at which you can download the data. Why does it do that? Because the network is a shared resource. If they give all the bandwidth to you, what would the other guys be do? The other guys, they will be very unhappy. So TCP is a fair kind of a protocol. If there are 50 users using a common shared network resource, a link or a sequence of routers, then the TCP will ensure, next chapter will tell you that the TCP will ensure that there is fairness. The entire bandwidth available, the entire network resource are divided fairly among those 50 users. Now you can cheat that. By creating multiple TCP connections. So if you look at these download accelerators, anybody use download accelerators? कितने लोगों ने use किया? Yes or no? Yes or no? How many people have used download accelerators? Yes or no? So one person has used it, one person has not used it. The rest of the guys, they don't know what a download accelerator is, or maybe they know and they just don't want to say. So many people have not used it. Some people have used it, some people have not used it. Anyways, so download accelerators, what they do is you can download a file from a server. As the name says, it's an accelerator. So what you do is that you don't have just one TCP connection. Behind the scenes, the download accelerator opens up multiple TCP connections with the server. And on each of those TCP connections, it behaves as if there are separate users. So if you open up 4 TCP connections, then you act as 4 different users, and the network resource is allocated to you 4 times of what you would have gotten if you had only one TCP connection. So that's cheating the network. But if everyone starts cheating, then nobody is going to get the benefit. So, so basically you can improve the HTTP to compensate for some of the TCP weak spots. Remember in TCP, we have to first send a request, get a response, and then three-way acknowledgement, three-way handshake. So there is some time wasted in that. So that's also a weak spot of TCP, that you first have to establish the connection. And after that, you are able to use that TCP connection. Okay? So that weak spot can also be addressed by HTTP somehow. Now, in addition to using this improved HTTP performance to compensate for the TCP weak spots, what we can also do is that we can also do what we call caching and replication. Caching and replication. And caching and replication, these are two separate things. We will talk about that in a minute. Caching and replication also increases the efficiency of transmission. So you can have faster downloads for the users. You can also have high availability for the users. Caching will do fast downloads for the users. Replication will do high availability for the users. Okay. Replication will also do fast downloads for the users. Caching and replication will also avoid network overload. And caching and replication also provides the cost-effective delivery infrastructure. So CDNs, for example, content distribution networks or content delivery networks, CDNs, they are part of the caching and replication solutions. Okay? And then you can also exploit, another solution is to exploit the economies of scale. So for example, you can have web hosting. You don't want to host things on your premises. You can outsource web hosting. You can also have CDNs, and you can also have data centers. See, the data centers, they provide what we call, sharing of resources, shared economy, in the sense that many people will rent the machines in the data centers to perform their tasks. They don't have to purchase those machines, and the people in the data centers, they will have hundreds thousands customers who will rent those machines in data centers, and they will perform their tasks, and a small rent is charged to each of these guys. So data center provider will be happy because they will be making money by putting up these data centers. Amazon is an example of that, and Microsoft Azure is also an example of that, which provides the cloud services in their data centers. So what they do is that they have a large number of customers, and each of those customers, they pay very little money, so they are happy. But since the number of customers is large, then Amazon and Google Cloud and Azure, they get lots and lots of money from these end customers. So it might be very interesting to mention at this point that Amazon started off as a warehouse selling company. They started off with selling books online, and then they expanded their portfolio. They were still selling stuff online, books and other stuff as well, and lots of other portfolio items that they were selling. Amazon, for the longest period of time, this business of Amazon for selling stuff online never made any money for almost 2 decades. Decades, they did not make any money. So, so maybe about 8 to 10 years into their existence, they came up with this idea of cloud. Jeff Bezos came up with this idea of providing cloud services. They said that we'll let people store their content on our servers, because people had the need to store lots and lots of content. And they provided what we call the Amazon Simple Storage Services, SQ. Those were the first services. Almost, I don't think that there was any other service available at that time where you can store stuff online at that scale. And that business supported the Amazon infrastructure and Amazon as a company. By providing revenue, they started making lots of money out of that. Okay. So HTTP performance, most web pages have multiple objects, You have a base HTML file, and within that base HTML file, you have embedded lots and lots of other objects, small images and maybe some video clips, etc. So HTML file and a bunch of embedded images. You have to send an HTTP request for each of the embedded object. So you have to send an HTTP request first for the base HTML file, get the base HTML file. Once you get the base HTML file, your browser will parse through the base HTML file. While parsing, it will encounter these embedded images, links to these embedded images, and then it will need to send request for each of these images, So how do you retrieve these images or these embedded objects? How do you retrieve these embedded objects naively? So you can do one item at a time. Yeah. Send a request, get a response, then send a request, then get another response. And before sending the HTTP request, what you can also do is that you can establish a new TCP connection. So new TCP connection, establish the TCP connection, spend time in that, send the HTTP request for the base HTML file, get the base HTML file, parse the file, and then while parsing, you realize that there are 3 other embedded objects. So again, open up a new TCP connection, send request for the first object, get that object, close that connection, open up a new TCP connection, send request for the second object, and then for the third object, do the same thing. So lots and lots of time is spent in this. Okay, so you have a new TCP connection per small object. For every small object, if you are opening up a new TCP connection, which was, by the way, default in HTTP 1.0, the initial version. In HTTP 1.0, this was the standard that every object will come on a new TCP connection. You cannot use the same TCP connection. Okay, obviously that's not a good idea. You establish the TCP connection once, and if you want something from the same server again, why not just use the same TCP connection again? You can just do that. Okay. So if the secretaries, they have already set up their communication channel, okay, the vice president, the president, and the CEO, they can all use the services from that secretary. The secretary, they shouldn't need to establish the connections all over again. Not in the case of HTTP 1.0. In the case of HTTP 1.0, for every HTTP request, you will need to establish a new TCP connection. Okay, so if you want to improve the HTTP performance, which happened in the later versions of HTTP, what you can use is what we call the persistent connections. And when we say persistent, that means the connection will persist. Not the HTTP connection will persist, but the TCP connection will persist. TCP connection on which HTTP is running. Remember, HTTP is using the services of TCP, so the TCP connection will persist. Okay, so maintain the TCP connection across multiple HTTP requests. You maintain the TCP connection across multiple HTTP requests. So including transfer subsequent to the current page, the client or server, they have the option to tear down the connection. Okay, but they should not do that. Okay? Obviously, when you request a web page from a server and you parse that file, that base HTML file, there will be many embedded objects. Many of these objects will be on the same server. So you can use the same TCP connection. If there is an object which is not hosted on the same server, it is hosted on some other server, what you will need to do is that now you cannot use the same TCP connection because TCP has endpoints. It's this server and this application. Okay. So a single TCP connection will have fixed IP addresses, fixed port numbers, fixed application on 2 machines. Okay. If there is a new machine, एक और सर्वर के ऊपर से आपने hosted कोई चीज मंगानी है, उसके लिए तो नया TCP connection establish करना ही करना पड़ेगा. Okay. But many a times, the server which is sending you the base HTML file, the embedded objects will also be hosted on the same server. अगर नहीं है वहाँ पे hosted तो नया TCP connection बनाना पड़ेगा. But if it is hosted on the same server, then you don't need to waste time establishing new TCP connection. You can just use the old TCP connection. Okay. So what are some of the performance advantages of using the same TCP connections? क्या फायदा हो जाता है उससे? उससे फायदा ये हो जाता है. So first of all, you avoid the overhead of connection setup and tear down. Remember TCP के अंदर हमने कहा था send a request, get a response, and then acknowledge. This three-way handshake will happen between the client and the server. So ये TCP handshake हमारे चल रहा है. So you avoid wasting time on that. अगर हर HTTP रिक्वेस्ट के लिए ये करेंगे तो टाइम वेस्ट हो रहा है. यू अवॉइड डूइंग दैट. ठीक है. सो ये इसका जो ओवरहेड है, ये टाइम एक दफा तो वेस्ट करना पड़ेगा. जब एक दफा हो गया उसके बाद दोबारा वेस्ट करने की जरूरत नहीं. ओके. देन देयर आर अदर एडवांटेजेस एज वेल व्हिच may not be that obvious, and some of those advantages will be clear when we see the next chapter about TCP, but I will give you a very quick overview of these. Allow the TCP to learn more accurate round trip time, RTT, round trip time estimate. Now, it turns out that you will need round trip time estimates for smooth running of TCP. TCP को run करने के लिए आपको round trip time estimates चाहिए होते हैं. Okay. On the basis of that, TCP does something. Okay. What is that something that we will not know until the next chapter? But if you have good estimates, the TCP will perform well. If you don't have a good estimate, the TCP may perform badly. Okay. So if it will allow the TCP to learn more accurate round trip time estimates. You send a packet and then you get a response. If you have a TCP connection which is established for a long period of time, many HTTP requests going on that TCP connection, that means your estimates about that connection, your estimates about that about the RTTs on that connection will keep on improving. Okay? If you tear down the connection after serving one HTTP request, then you will need to establish a new connection. Then it might take a different route. You may not be able to learn the RTT estimates accurately. Okay, so long-term estimates के लिए it is better if you have long-term connections. Okay, also TCP congestion window will increase. Now remember we said that TCP is a fair protocol. You cannot use the entire bandwidth which is available on the network. Why? Because many people are sharing it. TCP will be fair. Okay. Now, if the TCP is fair, it will give you a little bit of way. When you start sending something, वो आपको थोड़ा start करेगा. फिर वो देखेगा कि इसने तो और data भेजना है. Then it will give you more bandwidth. Then you have to send more data. It will give you some more bandwidth, more data and more bandwidth. And it will slowly ramp you up. Until you reach that fairness bandwidth. It will take you a certain period of time. आपको कुछ data भेजना पड़ेगा. उसके बाद you will reach that fair share. You will reach that fair share of bandwidth. You will acquire that fair share of bandwidth. That is your right. Okay. So TCP जो है वो क्या करता है? वो आहिस्ता रेट को इंक्रीज करता है. So when we say कि ये congestion window को इंक्रीज कर रहा है, we don't know what congestion window is at the moment. We will know in the next chapter. तो इसको वो आहिस्ता आपको रेट को इंक्रीज कराता है, फेयर तक जाता है. अगर एक TCP कनेक्शन बहुत शॉर्ट लिव्ड होगा, मैंने बनाया, उस पे एक HTTP रिक्वेस्ट भेजी, रिस्पॉन्स आया, बंद कर दिया, उस बेचारे को मौका ही नहीं मिला आपको वो फेयर शेयर तक लेके जा सकता. ठीक है. If you have a long lived TCP connection, long-lived TCP connection जिसके ऊपर multiple HTTP requests आ रही हैं, जा रही हैं, then it will have the opportunity to take you all the way to that fair share. Now, you might ask कि वो fair share के ऊपर जो है वो एकदम से क्यों नहीं लेके चला जाता? भाई इसलिए नहीं लेके चला जाता कि उसको अभी पता नहीं है कि वो fair share कितना है. उसको अभी पता नहीं है कि fair share कितना है, और उसको लर्न करना पड़ता है थोड़ी देर के लिए कि आपके पास और डेटा भी है भेजने के लिए या नहीं. आपको वो so let's say if 10 users are sharing a common resource, हर एक को वो शुरू में नया बंदा आया उसको 1/10 अगर वो दे दे, ठीक है, उसके पास इतना डेटा ही नहीं है बेचारे के पास भेजने के लिए, तो वहां पे तो आपने वेस्ट कर दी बैंडविड्थ. So it will also leverage the previously discovered bandwidth. इसका मतलब ये है कि लंबा कनेक्शन रखेंगे तो वो जो है प्रीवियसली डिस्कवर्ड बैंडविड्थ को मेंटेन रखेगा और उससे आगे अगर और इंक्रीज करना है तो वो कर देगा. सो persistent connections that you establish one TCP connection at the start and then you keep it and send all the HTTP request responses on that TCP connection. Remember, it's bidirectional. This is, by the way, the default in HTTP 1.1. This was not in 1.0. It is the default in HTTP 1.1. In addition to persistent connection, HTTP 1.1 has one more thing. एक और बड़ी मजे की चीज करता है. And what is that? That is what we call the pipelined requests and responses. Okay? So let's say even if you have persistent TCP connection, that means you establish the TCP connection in the start, and then you forget about establishing the TCP connection again. Okay? Send an HTTP request, answer aa gaya. Next, answer, next, answer. So you can send 2000 HTTP requests on the same TCP connection. But the way that you send those HTTP requests is that you send the first request and you get the response. Then you send the second request and then you get the response. Third request, you get the response, and so on and so forth. Okay? It would be nicer if you can pipeline the requests. Okay? आपने क्या करना है, आप ये सारी रिक्वेस्ट जो है वो एकदम से भेज दें. जितनी HTTP रिक्वेस्ट हैं वो एकदम से ही भेज दें. ठीक है. Now you might say कि जब तक बेस HTML फाइल नहीं आएगी तो आपको तो पता ही नहीं चलेगा कि embedded objects कौन सी हैं. That's okay. So for the base HTML file, you can send the request, get the base HTML file, and when you parse the base HTML file, you find that you have to get 3 more objects or 5 more objects or 50 more objects. So you send all those 50 requests one after the other without waiting for the response for all the HTTP responses that will come from the other side. So remember, HTTP request भेजते हैं तो response आता है. अगर मैंने 50 भेज दिए तो सर्वर 50 responses आपको दे देगा, one after the other. ठीक है. So this will save a lot of time for you. So you batch the requests and responses to reduce the number of packets. It is also possible to batch the requests and responses to reduce the number of packets. What that means is that multiple HTTP requests. Remember, HTTP is at the application layer. And in one HTTP request, okay, you can put one HTTP request in one packet. You can put 2 HTTP requests in one packet. You can put 5 HTTP requests in one packet. So एक पैकेट में भेज सकते हैं. ठीक है. नॉर्मली जो है अगर हम एक रिक्वेस्ट पर उसका रिस्पॉन्स आ रहा है तो फिर तो हम एक ही भेजते हैं. एक रिक्वेस्ट को एक पैकेट में भेजा, रिस्पॉन्स आ गया, मे बी 1 पैकेट, 2 पैकेट और 2000 पैकेट, जितने भी देर में वो रिस्पॉन्स आया, उस रिस्पॉन्स के अंदर डिपेंड करता है कि what is the size of the file which is given to you as a response. If the file is too big, it will take too many packets. Okay? Now, so pipeline requests and response means that you send the request and you get the response immediately. Asim, you have a question? Please go ahead and ask.
Sir, कोई स्पेसिफिक फॉर्मेट होगा या जस्ट लाइन फीड के बाद एक और नई रिक्वेस्ट आ जाएगी?
आई एम सॉरी, आपका सवाल पूरा नहीं आया. किसका फॉर्मेट होगा?
सर, मल्टीपल रिक्वेस्ट के केस में एचटीटीपी का कोई स्पेसिफिक फॉर्मेट फॉलो होगा या जस्ट एक रिक्वेस्ट के फौरन बाद दूसरी रिक्वेस्ट पे आ जाएगी?
एक रिक्वेस्ट के फौरन बाद दूसरी रिक्वेस्ट आ जाएगी.
और सर, अगर फर्स्ट रिक्वेस्ट का रिस्पांस लार्ज हुआ तो वो तो फिर मल्टीपल रिस्पांस नहीं आएंगे, पहले एक आएगा फिर बाकी आएंगे. ऐसे
That's okay. ऐसे ही होगा. मैं कोशिश करता हूँ यहाँ पे डायग्राम बनाने की. ठीक है. So फर्ज करें आपने TCP कनेक्शन एस्टेब्लिश कर लिया है. लेट्स अज्यूम कि आपने TCP कनेक्शन एस्टेब्लिश कर लिया. वो मैं यहाँ शो नहीं करूंगा. ठीक है. आपने ये एक रिक्वेस्ट भेजी, फिर उसका ये रिस्पॉन्स आया और रिस्पॉन्स में आपके पास पूरी की पूरी फाइल आई. सो व्हाट आई एम शोइंग हियर, ये पूरी फाइल है. ओके, ये पूरी फाइल है. ठीक है. अब उसके बाद लेट मी सी इफ आई कैन चेंज द कलर हियर. Yes, I can change the color. Then you send the second request. थोड़ा गंदा color है, but that's okay. Everyone can see this color? Yes? आसिम देख सकते हैं?
Yes sir.
जी, तो ये दूसरा response आ गया. ठीक है? This makes sense. So you send 2 HTTP requests and you got 2 responses. ठीक है? अगर इन दोनों को मैं अगर इकट्ठा भेज देता, उसके लिए मैं एक तीसरा कलर इस्तेमाल करता हूँ. सो रेड कलर इस्तेमाल कर लेते हैं. ठीक है, या हैंग ऑन, मैं इसके लिए मे बी ग्रीन कलर. ठीक है. सो अगर ये मैं 2 रिक्वेस्ट भेज देता कि ये पहले वाली और ये दूसरी रिक्वेस्ट, बोथ ऑफ द रिक्वेस्ट वेंट साइमल्टेनियसली. ठीक है. सो इनफैक्ट इसका कलर मुझे जरा डिफरेंट करना चाहिए था दूसरी रिक्वेस्ट का, मे बी ब्लू. सो ये जो दूसरी रिक्वेस्ट है ये ग्रीन नहीं है, ये ब्लू है. ठीक है, ये 2 रिक्वेस्ट आपने भेज दी, तो पहले आपको ग्रीन वाले का जवाब आएगा और फिर ब्लू वाले का जवाब आएगा. सो ये पहले ग्रीन वाले का जवाब आ जाएगा, ये यहाँ पे, विच इज बाय द वे द सेम एज वो जो पहले वो मैजेंटा कलर का आ रहा था. और फिर उसके बाद ये ब्लू वाले का जवाब आ जाएगा. सो यू हैव ब्लू गाय हियर. So I'm not sure. I have tried to, ये माउस पैड से तो इतना ही हो सकता है. So is
Right,
that,
sir.
does that make sense?
Yes sir.
ठीक है, तो ये देखें आप, ये ब्लू वाला दूसरा वाला HTTP का जवाब भी आपको यहाँ पे मिल गया. अगर आप अलग-अलग भेजते तो ये येलो वाला ये यहाँ पे जाके खत्म होता. So you saved some time. Okay. Any question about this? Any question? आसिम, आपका और कोई क्वेश्चन है?
No sir.
ठीक है, great. Okay. So multiple requests, they can be contained in one TCP packet, one TCP segment. Now, there is another way you can improve the HTTP performance. Persistence कर सकते हैं कि एक ही TCP कनेक्शन रखें, पाइपलाइनिंग कर सकते हैं कि बहुत सारी HTTP रिक्वेस्ट साथ ही भेज दें, उनके जवाब आ जाएंगे. There is another thing that you can do, but it's not technically, it's not part of HTTP. This is called concurrent requests and responses, which means that if you identify that you have to get 3 objects, एक आपने बेस HTML फाइल रिक्वेस्ट की, बेस HTML फाइल आ गई और बेस HTML फाइल को आपने पार्स किया, and then you figured out that within the base HTML file you have these 3 embedded objects. Now you need to get those 3 images from the server. So one thing you can do is that you can use the same TCP connection, send a request for one object, get the object, second object, get the object, third object, तीसरी के लिए और request भेजी and get the third object. So that's only persistence. So you send the 3 requests simultaneously. You send the 3 requests simultaneously, and then you will get the first object. Right after that, you will get the second object. Right after that, you will get the third object. So that's persistence with pipelining. But what you can also do is that you can open up 3 new TCP connections. If the objects are large, if these images are large, you can open up 3 parallel TCP connections. Obviously, you will need to waste a little bit of time in opening up these TCP connections. But what clients normally do is, वो थोड़े चालाक होते हैं, what they normally do is कि वो पहला वाला जब कनेक्शन खोलते हैं बेस HTML फाइल के लिए, in anticipation that the base HTML file may contain multiple embedded objects, वो एक pool of TCP connections और खोल लेते हैं सेम सर्वर के साथ. अगर embedded objects आई तो हमारे पास पहले से TCP कनेक्शन खुले हुए हैं, हम उनके ऊपर in parallel requests भेज देंगे. So use multiple TCP connections in parallel. So does not necessarily maintain the order of responses, and technically it's not part of HTTP because हर TCP connection के ऊपर आप एक अलग HTTP request भेज रहे हैं. So ये HTTP का part नहीं है, ये TCP की एक extension, TCP की भी extension नहीं कहना चाहिए. This is multiple TCP connections that you have opened between client and the server. So up here we have the client, and down here we have the server. So this client wants to get something from the server, opens up three parallel TCP connections, send a request, get a response for each one of them in parallel on three TCP connections, So as I explained, the reason that this might be faster is if these file sizes are large, you can probably waste some time setting up the TCP connection, or set up the TCP connection in advance in anticipation that you will have these objects to get, and then get these three objects in parallel. And the reason that you will get a better performance is because the network will think that you are actually three separate people who are requesting bandwidth from the network resources. Because remember, you need to fairly divide bandwidth. Divide bandwidth between each TCP connection. If the three TCP connections are owned by the same machine, that means this guy will get thrice the bandwidth of another guy who has only one TCP connection. Okay. So this way, the client is happy. The content provider is also happy. Why? Because the client is happy. The network may not be so happy, because if you have too many TCP connections, basically what you are doing is you are basically changing the behavior of TCP, making it unfair. Okay. So the network may not be happy. You might actually be overwhelming the network, because the network might think that there's too many TCP connections coming in. It may not be able to sustain that. Too much packet queued up. Okay. And some of the packets might actually get lost. Okay. So very quick scorecard. Getting small n objects. If you want to get some, it is very important that we say small objects. Small objects means कि उसको आने में ज़्यादा time नहीं लगने वाला. Okay. So the time will actually be dominated by latency. कि कितना time लगता है पैकेट जाने में और वहाँ से वापस आने में. Bandwidth पे dependent नहीं है. Why? Because the objects are small. If the objects were large, then setting up connection is very little time. It's the transport of data, transmission of data, which will take more time for large objects. Small objects के लिए ऐसा नहीं है. Small objects के अंदर latency is more important. So if you get the objects one at a time, then you get n multiplied by 2 RTT connections. Why? One connection, one round trip time for establishment of the TCP connection, and then you send the HTTP request, और HTTP request में ये दूसरे color से भेजूंगा. Then you send the HTTP request, and then you get the HTTP response. So you see one round trip time here, and then another round trip time here. And since the object is small, so ये red line जो है ये बहुत thin होगी. ये this guy here is very thin. So you spend 2 RTT per object. So if there are n small objects and you are getting them one at a time, then you will spend 2n RTT time. Okay. That makes sense. All right. If you open up concurrent connections, if you open up m concurrent connections, then you can get these objects. On m parallel connections. So the time will be reduced by a factor of m. If you have 2 concurrent connections, then you will have the time reduced by a factor of 2. If you have persistent connections, that means you open up the TCP connection once, okay, and then you don't open the TCP connection. Then you open up the TCP connection once. ये आपने ये TCP connection open कर दिया, ये 3-way handshake हो गया, okay, and then after that. You send the request for the first guy, get the first object, okay? And then you send the request for the second guy and get the second object. Third guy, third object. Nth guy, nth. So you see कि पहली दफा में पहली ऑब्जेक्ट लाने के लिए ये आपको 1 RTT एक्स्ट्रा स्पेंड करना पड़ा. उसके बाद फॉर एवरी ऑब्जेक्ट यू स्पेंड 1 RTT. फॉर एवरी ऑब्जेक्ट यू स्पेंड 1 RTT. So you have n plus 1 RTT time if you use persistent connections. Okay. If you use persistent and pipelined connections, if you use persistent and pipelined connections, then first you will have to open up this TCP connection. ये पहले TCP connection तो आपको ये open करना ही करना पड़ेगा. उसके बाद आपने सबके लिए रिक्वेस्ट इकट्ठी भेज दी, सबके लिए रिक्वेस्ट इकट्ठी पाइपलाइन करके भेज दी, एंड देन यू विल गेट ऑल द ऑब्जेक्ट्स साइमल्टेनियसली. एंड सिंस दीज आर स्मॉल ऑब्जेक्ट्स, इसलिए हमें पता ही नहीं चलेगा ये फौरन आ गई हैं. सो दैट मींस फर्स्ट उसके लिए आपको 2 RTT स्पेंड करने पड़ेंगे, बट आफ्टर द TCP कनेक्शन इज एस्टैब्लिश्ड, बाकी सारी ऑब्जेक्ट्स आपके पास, ऑल ऑफ दोज ऑब्जेक्ट्स विल कम इन वन सिंगल RTT. Okay. And again the reason is because the objects are very small. अगर objects बड़ी होती हैं तो ये काम ना होता. But what would happen if you have large objects? If you have large objects, then the time is dominated by the bandwidth. If you get the objects one at a time, then if the size of each object is f, which is reasonably large, then f over b is the transmission time for one object. ये एक के लिए लगेगा, and then you multiply this by n because you have n large objects. Okay. If you get these objects on concurrent connections, obviously, then you divide this thing by m. If you have capital M concurrent connections, this is divided by m. This time is divided by m. So what happens if you have a pipelined or persistent connections? Think about it. I will leave that thought with you. You can think about it. We'll share these slides. आज मैं अभी share कर लूँगा. If you have pipelined or persistent connections, then this time that you get for one single object, NF over B, ये इसमें कोई change नहीं आती. ये approximately वही time रहता है. Well, maybe थोड़ा सा incremental फर्क पड़ जाएगा because you are using pipeline and persistent connections. But since these objects are very large, most of the time is spent in actually transmitting those objects, not in the round trip times. Round trip times में इतना time नहीं खर्च हो रहा. उसके अंदर maybe 10 milliseconds, 20 milliseconds, 100 milliseconds, 200 milliseconds लगते हैं, लेकिन ये object को आने में seconds, minutes लग रहे हैं, which is the reasonably large time. So even if you use the pipelined or persistent connections, you are not going to get anything out of it. So जितना एक one at a time से time मिल रहा था, उतना ही बड़ी objects में ये time मिल रहा है, which means if you have very large objects, persistence and pipelining does not help much. The only thing that helps is getting more bandwidth, which means या तो bandwidth ज़्यादा करें या फिर आप multiple TCP connection खोलें, which indirectly gives you more bandwidth. Okay. So the solutions that we have talked about is improve the HTTP to compensate for TCP's weak spot. Next time we are going to talk about caching and replication. We'll talk about caching and replication in the next lecture. So Maham has a question. Is there a quiz this Sunday? We don't have quizzes in the course. We have tests, and we will have a test on this Sunday as well. We will have a test this Sunday. Okay. So any question about the material covered so far? HTTP, persistence, pipelining, parallel TCP connections. Caching and replication will be covered in the next lecture. And we'll try to cover caching and replications as well as DNS. I'm not sure if we will be able to finish that DNS in the next lecture, but we will definitely cover caching and replication in the next lecture. Any questions so far? Nahi question? No question. All right. So Maham, you have sent a private question. ये जो है I will be available after the lecture is finished. I will be available on the link. वो जो ऑफिस आवर्स वाला लिंक है, आप उस पे ज्वाइन करके आप क्वेश्चन पूछ लें जो भी पूछना है. Okay, so I'm going to finish this meeting, finish the lecture here, and we'll upload the video on YouTube channel. Also provide the link on Piazza page. Okay, thank you.